Okay, so hopefully this works, and if it does, I'm going to post it on the course website. So first thing I want to do for today is to go over the syllabus. I did not bring you printed copies. I'm going to try only to distribute things to you that I absolutely have to, like quizzes and exams. So things like homework and the syllabus will just be posted online. Okay, so let me go to our course webpage. So our course webpage, and I think I sent this to you in an email, but it's my name, which is jpantone.com, and you click Math 2100/2350. Okay, so I'll talk more about the website in a little bit, but let me go straight to the syllabus, and we'll talk about this for a little bit. Okay, so my office is in Cudahy Hall. My office hours are not scheduled yet. We're still trying to figure out a lot of things in the department, but I will probably know those for sure by next week. Now, for this week, I'm going to have an office hour, like a temporary one, on Friday at 10 a.m. on Microsoft Teams. So all of our office hours are going to be virtual, which I know is a little bit weird, but I really encourage you all to come to office hours, even if you want to just stop in and introduce yourself. So during the office hour, I will be just sitting there with my webcam on. I'll be really lonely until somebody comes into office hours and talks to me. You can just pop in at any time and say hi. And I want to repeat this because sometimes if we have freshmen in here, they don't realize that office hours, you don't have to make an appointment. You don't have to email me ahead of time. You just pop in at any point in time. Okay? I've had people who were juniors or seniors come to office hours and be like, wow, this office hours thing is really good. How come I never did this before? So maybe give it a try if you haven't before. Let's go to the textbook. So the textbook we're using, it has this blue and white cover. We are going to use it really extensively, so you need to get a copy of it one way or another. There's only one edition as far as I know, though. Any questions about the book? Stop me at any time if you have questions. Course websites. So the main website that's going to have most of the information is the one that I showed you at jpantone.com, and I'll go back and show you that in a little bit. We're going to use D2L almost entirely just for grades. So I'll put your grades into D2L, and that's where you can see your scores. And we'll use Microsoft Teams for virtual office hours and things like that. Okay, now the big thing that's different about the way that I run this course from the way some other people do is the grading scheme that I use. So I use a grading scheme, this will be the 4th semester now for this course, called specifications-based grading. And the idea is that instead of getting a numerical score, like a 90% or a 5 out of 10 or something on each question, you get a letter grade according to a rubric. You either did the question totally correctly, or mostly wrong, or you left it blank. So every question that you do in this class is just going to get one of those 4 scores, and then your final grade will depend on how many you get of each of those. So I'll explain it a little bit. Let me say that it sounds complicated the first time you hear it. Every student has said that so far, and by the end of the semester in my anonymous reviews, people always love the grading system. So it's going to seem a little bit strange and complicated at first, but there are a couple big benefits to you that I think you'll like. The whole point of this is, especially in a course like this, where we're not just doing calculations the whole time, we're actually writing theorems and writing proofs, and it's kind of a different type of math than you might be used to. We want to emphasize understanding the material over just memorizing the material. Memorizing can kind of help in calculus, but it's not going to get you very far in this course. And because this course can be pretty challenging early on for some people, because writing theorems and writing proofs is a strange thing at first, I want a grading system that's going to give you guys the opportunity to revise your work. So one thing you'll see in this system is that every single homework question, you will be able to revise as many times as you want until you get it right for full credit. Quizzes and exams, you will also be able to revise with some caveats that I'll talk about in a minute. So that's kind of the trade-off. It's a weird system for you to get used to at first, but you get to revise your answers over and over again until you get them right. That's a lot more grading for me, but it means you guys will actually end up understanding something once you get it wrong the first time, instead of just moving on to the next assignment. Yeah? Yeah, absolutely. I'm going to repeat the question so that my microphone picks it up and you guys all hear it. The question was, if you're revising something, are you allowed to come ask about it in office hours? The answer is you can ask about anything in office hours. You can ask about it the first time you're doing it. You can ask about it in revisions. You can ask about quiz questions you're revising, exam questions you're revising. I'm not just going to give you the answer, but I'm going to help you figure out how to do it. So yeah, you can ask anything in office hours. Yep. Any other questions? Okay. Yeah, so before I move on, let me just say a couple things. Everybody needs to be wearing a face mask. I think everybody is, and I appreciate that. We have been instructed to ask you to leave if you're not. So it is really important that you wear the face mask. If you come and you just forgot it in your dorm, I'm going to try to always have some extras with me. It means you have to wear a mask that has math symbols on it, which is a little embarrassing, but I'll have one that you can borrow for the time we're here. It's also totally okay to have water or some kind of other beverage. I've got coffee here. And you can just pull down your mask or whatever, take a quick sip and put it back. But we've been told that we should not allow any eating of food. I know that's a little inconvenient given that it's a 12 o'clock class, but any questions about that? Okay, I said that mostly because I want to drink a coffee, so. Okay, so in this course, you're going to be graded on 5 different things. First is homework, second is quizzes, third is exams. Those are pretty standard. The fourth one is class participation. Now for me, class participation basically means that you don't miss too many classes. Obviously, if you have an excused absence, that doesn't count against you, and I'm not taking attendance. So this is just like, if at the end of the term I look at the roster and I say, who is that person? You have not participated enough. Participation is also when I ask questions to you guys, occasionally raising your hand to answer, asking questions. Basically, everybody will get credit for participation as long as you are here most of the time and being active in the class. If you fall asleep every day, you might not get the participation. So for everybody, that should be fine, as long as you're here and engaged. The fifth one is part of the specifications-based grading mentality, which is about revising your work. So at the end of the semester, like the last week, I'll ask you to write like a 1-paragraph summary of how you felt about the specifications grading program. Did you learn anything from it? Do you think it helped you? Do you think it hurt you? And when you revise assignments, I'll ask you to fill out a little sheet that says like, why do you think you got it wrong the first time? How could you prevent making these mistakes again? It seems a little silly, but the idea is not just to be revising, because you guessed the first time. The idea is you want to figure out what went wrong, how can I do better on the exam? And so as long as you fill out that little sheet and write that 1 paragraph at the end of the semester, you'll get full credit for the demonstrating productive failure. So the first 3 are the main ones, the homework, the quizzes, the exams. The second 2 are not something that you should worry about at all. Any questions so far? Okay. Every homework question, every quiz question, every exam question will be graded with one of 4 letters. It will either be, I don't think I can write on this screen, it will either be an E for excellent. Let me zoom in here. E for excellent, that means that you basically got it entirely right. Maybe you have some little tiny mistake, but you basically got it entirely right. M will mean kind of good enough. It means you got it mostly right. Maybe you had one tiny error or maybe one medium error that caused you to get the wrong answer, but you had most of the right ideas. P for still progressing. So that means you didn't get it right, but you can revise it and try again. So still progressing is a kind of a nice way to say you got it wrong, but this is a step in the process, and eventually you'll get it right. And the last one, I, incomplete, is either I literally can't read anything you wrote, or what you wrote had nothing to do with the problem, or it was blank. So that's a pretty rare one to get. You should think about E and M as basically being passing, like you did good enough, and P as being you still have some work to do. So each homework question individually will get one of these letters. If you have 5 questions on the homework, you'll get 5 of these letters, 1 for each question. If you have 2 questions on a quiz, you'll get 2 of these. If you have 10 questions on an exam, you'll get 10 letters, and that will be your exam score. So this always creates a little bit of discomfort at first because, I don't know, students, we're all used to seeing like a percentage, like 85%, okay? I know what that means. But if you get 6 E's and 2 M's and 2 P's, what does that mean? But you'll get the hang of it, I promise, as we go. Okay, any questions? Okay, so I'll talk a little bit about those 3 types of assignments, homework, quizzes, and exams, how many we're going to have, when we're going to have them, and things like that. And then I'll tell you at the end, this is the complicated part that can seem a little scary at first, how your scores turn into your final letter grade. Okay, we're going to have homework assigned approximately every other Wednesday, and it will be due 2 weeks from when it's assigned. If we have a break in the middle, that could be extended or could change a little bit. So there's going to be 6 homework assignments. Each one will have 6 to 10 questions. Some of those questions will be really short, some might be medium, some might be longer. I do take late homework up to 24 hours. This is something that I'm going to talk about in a minute. It costs you some tokens. So as part of the revision system, you start with a bunch of tokens, and you can spend them to turn in late homework, for example. You can spend them on other things. You can get them by doing things as well. So I'll come back to that in a minute. We're going to, in this course, in part because I'm going to take all of the homework virtually, and in part because I'm trying to think ahead for the possibility where we end up fully online in some amount of time, all the homework is going to be turned in on D2L, and so I want you guys to type the homework. Now, typing math is something that can be a little bit tricky at first. There's a typing system called LaTeX that all math majors will use at some point. A lot of CS majors might use it at some point, and so we're going to learn how to do it as part of this class. You don't have to go learn it all on your own. We're going to talk about it probably starting on Friday. It's really not that hard. It's like you type all the words you want to write, and then when you need some math symbols, you just type some certain words for the math symbols. So it's an important part of a math class. Eventually, you will learn how to do this, and so I decided for this semester at least, we're going to learn how to do it here, since we're going to have to turn them in digitally. Now, another reason that it's really, really good to type your homework in this class is that you'll be doing revisions. So if you handwrite your homework and you want to redo a problem, you have to handwrite that problem again from scratch, and that can be a little annoying. If all you forgot is a sentence, or you have to turn like a true to a false or something, and you have it typed, that just takes a couple seconds, and you don't have to rewrite anything. So it's going to make it easier for me to grade. You're going to learn the LaTeX skill, which is important, and you'll be able to do revisions easier. Any questions? Yeah? So the question was, how much is going to be writing versus actual math? It will be 100% actual math, and some of that math will involve writing. So for example, we're going to learn statements that are called theorems. That's a mathematical statement that's true. And we're going to learn how to prove them. That means how to rigorously justify with one logical step after another logical step after another that it's true. You kind of do this in calculus even if you never use those words because you solve some problem and you're showing all your steps. We're doing the same thing, and we'll use a lot of math symbols and stuff, but our steps will also be English words and sentences that make a logical argument. Does that answer your question? Any other questions? Okay. So that's the homework. You'll have 6 to 10 questions every 2 weeks. I'm also, for each lecture, going to recommend several exercises from the textbook. So this is not on the course website yet, but after each day, depending on when we finish the lecture, I'll go on the course website and pick a couple right out of the textbook. And those are not graded, not collected, but it's a very, very strong recommendation that you at least look at a couple of them. My personal feeling is that if you never look at them at all, you don't have nearly enough practice. Some people might only need to do a couple before they feel like they understand the material. Some people might have to do all of them or even ask for more. It just depends on your level of comfort. You can always ask about those in office hours, and I really encourage that. Okay. So that was my phone that buzzed. You may or may not have heard it. I have an 8-month-old daughter who we just put in daycare last week, so I have to keep an eye on my phone in case they call if something happens. So you might hear it buzz, and I apologize for that, but I'm going to just have to keep an eye on it. Okay, that's homework. Quizzes. We're going to have a very short quiz with 2 questions every Friday. Not this Friday, but the next week, except for when we have exams. Now, the quizzes are not meant to be very stressful. The idea of the quizzes is I just want to make sure that you're keeping up with the lectures, and it's a kind of a way to force you or to trick you to not cramming for everything right before the exam, because that's tough to do in a class like this where you're learning how to write proofs and write theorems and things. The questions from the quiz will always come verbatim from the suggested homework. Not the written homework that's actually graded, but the ones that I'm going to suggest from the book. So again, that's another way to bribe you into looking at some of those questions. So not meant to be very stressful, especially because I'm telling you ahead of time what the questions might come from. But that will be every week, 2 questions. You'll usually be like 15 minutes, not any longer than that. Okay. Exams, we're going to have 3 midterms and a final. Normally I do 1 or 2 midterms, but given the kind of weirdness of this semester, I wanted to do more spread out lower stakes exams instead of like 1 or 2 really high stakes exams, given that craziness might happen at any point in time. So we're going to have 3 midterms and a final. The midterms are going to have 6 questions. We'll take them in class as long as classes are still in session. So it'll be a 50-minute exam. The final exam will have 10 questions. So that means the total number of exam questions is 6 plus 6 plus 6 plus 10, which is 28. And the reason that I'm telling you the exact number of questions is you'll see that that's part of how this grading scale works. Okay, any questions? Okay, revisions. So every question that you do, everything that's graded in this course, you'll have an opportunity to revise. You can revise anything as many times as you want, and you're revising it to get full credit. You're not just getting partial credit back. So that is meant to really help you do well in the course and to help you actually learn the material instead of just getting an answer wrong and then moving on and forgetting about it. And that's kind of the critical part of this grading system. I'll remind you of this when it's time because you won't have an assignment due for a couple more weeks, but you have 1 week to do revisions from the time that I hand it back, and that's so that you don't come at the end of the semester with like a big stack of wanting to revise everything. So you have 1 week to do revisions, and you can revise. I haven't decided exactly how I'm going to collect those. I have to kind of figure out if D2L will let me take an assignment again and score it again, and so I'll kind of test that out and let you know. But you can revise anything that doesn't get an E. So for example, if you get that second best one, which is an M is usually pretty good, and you want to revise that to an E, you can still do that. You can revise anything. The only thing you can't revise is if you leave the question blank. You have to at least make some attempt, even if it's a very small attempt. Try to write a sentence and then say, I don't know what to do from here. That's fine. If you leave it totally blank, you can't revise it. Everybody understand that? Okay, I'm always going to keep the higher score. So if you revise it and do worse, which happens sometimes, I'm going to keep the higher score. You don't have to worry about that. And if you revise it, so like say you get a P, and you revise it, and you get another P, you have another 1 week to revise it again, and another 1 week. You always have 1 week from the time I give it back to you. So I've had students that need to revise a certain question 4 or 5 times. That can happen if it's a hard question, and that's fine. You just have 1 week from each time you get it to revise it again. Okay, so I talked about class participation. I expect you to be in class, awake, active, and then I said in the syllabus, working with your group. Normally I do a lot of group work in this class. We're not going to be able to do that since we can't get that close to each other, so that part's not so important, but just that you're participating if I ask questions and things like that. Okay, now the last part of this grading system, this is the part everybody thinks is confusing, so I'm just going to go over it briefly. We'll talk about it more once we get our first assignment back. Here's the translation between what scores you get and your letter grade. Okay, give me a chance to explain this before you panic and just get up and leave the course. If you want to earn an A, for example, this tells you what you need to accomplish. If you accomplish everything in that A column, then you earn an A. So for example, if you want to get an A, then on your homework, you need to earn at least 22 M's or E's. M and E together are the ones that are like basically passing. So out of the 24 homeworks, you need at least 22 M or E. That sounds like a lot at first, 22 out of 24, but given that you can do revisions, people usually have no trouble with that. You also need 14 of those to actually be E's. Okay, this is the part that confuses everybody for a little bit. So at least 22 out of your 24 have to be M or E, but of those, 14 have to be really good. They have to be E's. So if you get 22 M's, that's not good enough. The goal is that I want some big percentage of your answers to be at least mostly correct, but you still need to get some smaller percentage 100% correct. If you never get a problem 100% correct, that's not really worth an A. So to get an A, let me repeat that one more time. On your 24 homework scores, you need at least 22 to be M or better, and at least 14, a smaller subset, to be 14 or better. On the quizzes, this is not correct. So the quizzes says 12 scores. There's more than that. I just forgot to change this on the syllabus. There are, I think, 16 or 18. I'll check that in a minute. But of the quiz scores, you need 14 to be M's or E's, 9 to be perfect to be E's. Same kind of thing with the exams. I forgot to change these ones on the left. Sorry, these tallies on the left, so you can ignore those. But the numbers in the columns are correct. Class participation, you need to have that check mark to get an A or a B. And demonstrate productive failure, you need that check mark to get an A or a B. Nobody normally has problems with those two, so you shouldn't worry about those. Okay. To earn a B, for example, to earn a B, you have to satisfy everything in the B column. So to earn that grade, you have to satisfy everything in that column. To earn a C, you have to satisfy everything in that column. To earn a D, you have to satisfy everything in that column. Before I talk about plus or minus grades, are there any questions? We'll talk about this again when you get your first assignments back. Like I keep saying, I know it sounds a little weird. By the end of the course, students always love this, though. Okay, the only thing that I didn't say so far is how you get a plus or a minus grade. So I said, for example, to get a B, you have to satisfy everything in the B column. If you satisfied some of those rows even higher in the A column, that can bump you up from a B to a B plus or a B to an A minus. So out of the 5 categories, the homework, the quizzes, the exams, the participation, and the demonstrating productive failure, out of those 5, if you meet everything for 1 letter and a higher letter for 2 of them, you get bumped up to the plus. If you meet everything and a higher one for 4 out of the 5, you get bumped up all the way to the next minus. So most students end up with a plus or a minus grade because of the, for example, the class participation and the demonstrate productive failure are pretty easy to do. So if you satisfied everything for a C column, I don't think I have a laser pointer here, maybe I'll bring one. If you satisfy everything for the C column, but you also have your participation and your demonstrating productive failure, that's 2 that are higher, so you go up to a C plus. Any questions? Okay. The last bit, I think I said the last bit was the last bit, but this is the last bit, is the token system. So the only reason we have this is that I can't let you revise every single exam problem because then everybody would get everything correct and it wouldn't be a grading system that really made sense. So everybody's going to start the course with 8 tokens. And if you look on D2L, you'll see a column that will always tell you how many you have left. So I'll keep track of that for you. So you start with 8. You can earn extra tokens by coming to office hours. So if you come to office hours on Microsoft Teams, you'll get a token. And you can do that up to 6 times per term. So that's really easy. You just come in, you say hi, you get an extra token. You can get a token if you study for a quiz or an exam in a group of at least 4 students. And obviously, virtual study groups are preferred there. All you have to do is email me. Tell me, hey, this is who I studied with. This is where we studied. We thought it was good. We thought it was bad, whatever. And you get a token. And then the last one, if you bring a math news story to tell the class about, you can get 2 tokens. You only have to stand up here. You can put something on the projector if you want for 1 or 2 minutes. Say, this is the news story I found. Here's how it relates to math. Here's why I think it's interesting. Just email me ahead of time like it says here, and then you can do that too. Yeah?
So I've got some friends who are also taking discrete math from other professors. Would it be possible to study with them, assuming they're in the same track?
I would say yes if they're in the same spot. My guess would be that all of us are going to do the sections in a slightly different order depending on our preference, or might leave out some or add in others. So that would be fine if they are studying the same material. But for example, by the time we get to exam 1, I'm sure that the cutoff for us is going to be different for other people. So it'd be okay, but maybe not so helpful depending on the details. I didn't repeat the question, sorry. The question was if you study with the people in a different section of this course, does that count? Any other questions? Okay, now what do you spend tokens on? Revising homework costs no tokens. You can do that as many times as you want, over and over again, as many problems. Revising a quiz question costs 1 token. Revising an exam question costs 2 tokens. Now, it's really, really rare that somebody runs out of tokens in the course because you can always come to office hours up to 6 times and get those. You can study in a group. You will probably have plenty of tokens. It's really just to make sure that you don't try to revise all 28 exam problems, which would be pretty tough on you. Any questions? Okay. And like I said in both of these, if you have a suggestion about an interesting way to spend a token or earn a token, I'm open to suggestions. The one I didn't mention is that you can spend 2 tokens to turn in a homework assignment up to 24 hours late. That's pretty rare that I've had students take advantage of that, but that's something you can do if you need to. Okay, so a couple classroom policies. Office hours I talked about. I will set the times soon and let you know for sure. but they're going to be over Microsoft Teams. We talked a little bit about LaTeX. That's what the system that we're going to write our homework in. Now, that looks like the English word latex, but the way most people pronounce it is LaTeX. It's Latin or Greek or something. So we'll worry more about that on Friday. If you think that I graded something incorrectly, that definitely happens. You should bring it to me within 1 week, and I'm happy to take another look at it, make sure that I graded it correctly. Do you guys hear that noise? Is that just the AC or something? Okay. Maybe we have crickets in here. Classroom conduct. So I think that we'll have a good class if you guys are willing to answer questions. One thing that I always say is that my favorite answers that students give are the wrong answers. Because if you give me a wrong answer to a question, that tells me something. It tells me, oh, I need to cover this a little bit more. If I say, does everybody understand, and you all just nod your heads or stare at me, then I'm going to believe you actually understand and move on. But I'd much rather know if you're confused. So in my experience, if you have a question, normally half of the class at least has the same question, and nobody's brave enough to raise their hand and ask it. So go ahead and raise your hand if you have a question and let me know. I would prefer if you could keep your phones away in class as much as possible. If there's something urgent going on, I understand. But I've had a lot of students say that they look at their phone for a minute because they know something, and then by the time they look back up, they realize, oh, we went way past the part that I already knew, and then they get kind of lost. So it'll be better for you if you could keep your phones away. Return papers. So you should keep anything graded I give back to you. In case something happens on D2L, like I enter it incorrectly, and that happens sometimes, or D2L grades get lost, you need that graded paper to prove to me that you got the grade you got. So you should hang on to those throughout the semester. Okay, this one's important, the homework collaboration policy. I want you to collaborate on homework. I really encourage you guys working together as much as possible, studying together, learning the material together on your homework. But I want to make sure that you understand what that means. It does not mean that you can turn in one copy for 4 people. It does not mean that you can all 4 of you write your answers together and they're verbatim. That's considered cheating. I want you to talk about the problems together. You can sketch out a solution together. You can discuss it. But then you need to sit down by yourself and be able to write up the answer. A good way to judge if you collaborated too much or not is if I take your proof and I ask you, like, hey, can you explain what this line means? If you can't answer that, then that means you haven't done the work on your own enough. So I really want you guys to be able to talk to each other about this, but when you actually write up your answers, you should be doing that on your own to make sure that you understand them. And same thing for, not the same thing. For revisions, you should do that on your own, especially quiz and exam revisions. But when you're doing the homework the first time, I definitely want you and I encourage you to collaborate. Any questions? You can always ask me, email me if you're in doubt about what's okay and what's not. For almost every textbook in the universe, your professors know, we all know that all of the answers are online somewhere, or you can get them quick enough. So, the suggested homework from the book, you could probably just Google it and find the answer. But in my experience, especially when it comes to writing proofs, the whole point of writing the proof, the whole point of the homework is to make you suffer through the pain of figuring out how to do it the first time, because that's where the actual growth comes from. It's sitting there and being confused and thinking for 10 minutes and maybe flipping back and forth, and then you have the aha moment that tells you how to do it. That experience is what you actually learn from, not just the act of writing the answer. So really encourage you to try them on your own and ask about them in office hours if you need to. Okay, I think we're done. The rest is kind of boilerplate language about expectations in this era of COVID-19. You have to wear masks. I already talked about that. Please try to stay at least 6 feet apart. The seats are all fine. When you guys leave class, please try to leave a little space. Don't all bunch up in the hallways. Make sure that people have a little space to be able to get out the door. What else? And then at the bottom, I won't read these, but I have a couple of quotes from the anonymous course reviews. I asked students to give some advice to future students, what helped them, what didn't, and so you can read these and maybe see what past students who use the same grading scale had to say. Okay, the last thing I want to say is that this is bound to be a very weird semester in a lot of ways. I've never taught in a theater before, for example. So if something happens, if one of you gets sick, if one of you needs to leave town, whatever happens, try to stay in constant contact with me. If you miss class for 3 weeks and then you email me and say, oh, hey, I was sick for 3 weeks, what can I do? It's going to be tough. I'll still try to help you, but it'll be tough. If you let me know ahead of time, whatever's going on, I can work with you and we can try to make it work. So reach out to me at any time with anything and we'll try to make it work. Okay, I'm going to leave the syllabus now, go back to the website. Are there any questions before I do that? Yeah. Yeah, the office hours, my plan for now is that they're all going to be virtual on Microsoft Teams. If that's an issue in some way, if you don't have a camera or something like that, get in contact with me. We can try to figure something out. But my plan is to have them all be virtual, yeah. Yeah. Sorry, can you say that again? There will be, but there's no help desk for this course. So the question was, will the help desk be open? And Marquette has a help desk for Calc 1, Calc 2, Calc 3, maybe differential equations, maybe a couple other courses. But this class doesn't have a help desk. Any other questions? Okay, let's go to the course webpage. I'll just point out, I'm already in Safari, okay. So a lot of important information is going to be here in terms of what we're going to cover each day. When these screen recordings that I'm doing are ready, I'm going to post them also. I guess I'll put them on YouTube, but then I'll post the links here as well. Homework will be posted here. Homework solutions will be posted. Exams and exam solutions, once they're done, that will all be posted here. So probably the most important part is near the bottom. That's the daily calendar. So for each day, I'm going to put what we cover. And I'm going to put on the right-hand column, it's not there yet, but I'm going to put suggested questions from that section. So today, once we're done, we're going to have about 10 minutes. We'll start section 7.1, which is just a little bit of a taster of something at the end of the book. But we're not going to finish it today. So I'm not going to assign you suggested homework from a section until we finish it. That'll be on Friday, and then I'll write the questions there. This also has a list of when all the due dates, all the quizzes, all the exams are. So the first homework will be assigned on Friday. It'll be pretty short because we just started. And it will be due, normally they're assigned on Wednesdays, but I didn't want to assign something the first day of class. So it will be due Wednesday, September 9th. From that point, every time you turn in a homework, you'll get the next one and have 2 weeks and so on. The first quiz will be next week, and I'll tell you by probably Monday what the topics are. And remember, the quiz questions come verbatim from the textbook problems. So that'll help you make sure that you're ready for them. The exams are here. And the final exam is Thursday, December 3rd. I think we have a time scheduled for that too. I don't remember what it is off the top of my head. Okay, any questions? Okay, all right, people in the back, can you still hear me okay? Okay, stop me if I get too quiet. All right, so I think that is everything I wanted to say about the syllabus. Let me jump back to Notability here. And that's big enough that everybody can see it, I hope. Let me write the one thing I said out loud but I didn't write is that I'm going to have a temporary office hour. Meaning this is not a normal scheduled time, but since I don't have a scheduled time yet, I wanted to give you at least some office hour this week. That's going to be 10 a.m. to 11 a.m. on Friday, this Friday, on Microsoft Teams. So like I said, we have a D2L page. You know about that. We also have a Microsoft Teams page. Mostly that's just going to be for our virtual meetings. But there are also little chat channels where if you have a question, you could email me, but you could also just ask it there. So you could say like, hey, I missed the homework. I missed the announcement. Was there anything important in class today? Something like that. And I can respond or somebody else can respond. That's also where you're going to find the link to join the office hours. There's a chat channel called Office Hours, and I think I already posted a link there to the calendar item. If not, I will later today, and you just click that at 10 a.m. or whenever in between that time and join. Okay, any questions? Okay, so we've got about, looks like 13 minutes left. We're going to talk about section 7.1 in the book. Chapter 7 is all about a topic called graph theory. That depending on which computer science classes or math classes you take, you might see a lot of it. Let me just ask, how many people in here are computer science majors? Could you raise your hand? How many are math majors? And how many are other? I guess a couple. Okay, so we're going to hit a lot of topics in this course that are pertinent to math and computer science and others. Some might be more relevant to math, some more relevant to computer science, but they're all pretty closely tied together. Okay, so this is section 7.1. If you ever can't read my handwriting, please let me know. It's not that great, and I wish I had something that I could like prop up. It's a little awkward to be writing like this, but definitely let me know if you can't read my handwriting. Okay, we're going to start with a definition. I'm going to tell you what a graph is. Now, if you're used to calculus, you might think about a graph as like something in the xy plane. We mean something totally different when we say graph here. So our first definition, that stands for definition, is that a graph is a set of nodes, or sometimes they're called vertices, connected in pairs by edges. So let me draw an example for you. I'm going to draw 5 nodes. So we just draw them as dots. So that's 5 nodes, or 5 vertices. And then I'm going to connect some of them in pairs. So maybe I've got a connection between those two, and these two, and these two, and these, something like this. Now there's a lot of edges that I could have drawn, but didn't. I could have connected these two together, or I could have connected these two together, or even this one and that one. So they're not all connected, but some of them are. And then how many edges does this have? It has 1, 2, 3, 4, 5, 6. 6 edges. Are there any questions? Okay. You have probably seen graphs or heard them referred to in a lot of different contexts. One that you hear a lot these days is in terms of social networks. And there's a lot of mathematicians and computer scientists who study social networks and try to see how everybody's connected. So one way that you might turn a social network like Facebook into a graph is that you could have the nodes be all people. Let's say like with a Facebook account, for example. Does anybody want to give an example of what the edges could be? Yeah, can you remind me your name? Tony, okay. I'm going to keep asking until I can start to remember. Yeah, Tony? Yeah, so we could put an edge between two people if they are Facebook friends. So let's say edge between two people if they are friends. And so people ask questions like how many, what is the furthest distance between two people? Obviously not everybody on Facebook is friends with everybody else, but is there a length 2 path between everybody, or 3 or 4? What's the longest distance? You can also do this with any kind of actual like physical social network. So for example, we could do a version of this where the nodes are the people in this class, and the edges, we draw an edge between two people if they know each other in real life. So is there anybody here in the class that knows anybody else in the class? Or are we all strangers? Okay, so you guys know each other? What was that? Yeah, so if we drew this graph, we would have a node for Anthony and a node for, what was it? Sorry, I can't hear you. Can you spell it? Oh, Jack, sorry. something about the masks and the way this room is shaped, it makes it really hard to hear you guys. So we would have a node for each of you, and you'd have an edge between them because you know each other in real life. Any questions? Okay, here's another example. We could think about, this is a kind of a strange thing to make a graph of, but we could make a graph where the nodes are all 50 states. And the edges, we put an edge between two states if they border each other. So let me draw a tiny portion. I'm not going to draw all 50 states, but let's draw a little bit of what this graph might look like. Now, we're not drawing the actual borders of the states. All the states just become dots. And then we connect two dots if they actually share a border. So I'm going to draw a little bit of the country. I'm going to start down with Florida, because that's where I'm from, born and raised in Florida. And I'm going to draw a little bit of the southeastern U.S. there. So Florida, for example, borders Alabama and Georgia. I'm going to try to keep them in roughly at least the same relative location as they are on the map. Florida borders both of them, and they border each other. Georgia borders South Carolina. And North Carolina, it actually does a little bit. I had to check, but it borders it a little bit. And it borders Tennessee. Let me move this down and give myself a little bit more room. Okay, South Carolina and North Carolina border each other. Tennessee and North Carolina border each other. Virginia borders North Carolina and Tennessee, as well as Kentucky. We're just going to add a couple more. Kentucky borders Tennessee and Missouri, so we're kind of going a little bit in a circle here. Missouri borders Tennessee and Arkansas. Arkansas borders Mississippi and Tennessee. And then we connect this back through. Mississippi borders Tennessee and Alabama. Okay. So, and Tennessee borders Alabama. Okay, that was a little bit of work, but it's going to demonstrate something that I want to show you pretty nicely. Of course, we would draw a lot more. Somewhere out here, we have Alaska. Alaska is not connected to anything, right? It does not border any other state. And so it's just a node not connected to anything, which is totally fine. That's allowed. Same thing with Hawaii down here. And then obviously a lot in the middle. Okay, now here's the question I want to ask. The question is, how many colors do you need to color the states such that no two bordering states have the same color? If you look at any map of the United States that has colors for the states, you're going to notice that you never have two states that touch that have the same color. So that's a reasonable question to ask. If I give you a map of the US, how many colors do you need? Well, you obviously can't do it with one color, because lots of states border each other. You can't do it with two colors. We're going to show, not today because we're almost out of time, you can't do it with three. But if you look at any map of the US, it probably uses 4 colors. So the question is it possible to need 5 or 6? Do we always need 4? That's the kind of topic that we're going to explore. Before we leave, let's just try to do that with this graph. Let's say how many colors. So let's start and pick one color for one state. Let's say Florida is going to be, that's too big. Let's say Florida is going to be orange. Okay, now we need a color for Georgia. We can pick any color we want except orange. Orange is already touching, Georgia touches Florida, so it can't be orange. So let's pick green. Okay, we're good so far. Now, Alabama needs a color, and it's touching Florida, so it can't be orange. It's touching Georgia, so it can't be green. So this tells us already that we definitely need at least 3. So let's pick a third color. Let's do blue. And then we can try to go all around the states and pick some colors. South Carolina, well, we don't need a new color. We could do orange or we could do blue. Let's just pick blue. North Carolina can't be green because it touches Georgia, and it can't be blue, so let's make it orange. Now you can just go around and pick colors. You might not do it in the most efficient way, but at least you can try. Let's make those orange. Let's make these blue. Let's make Virginia green. And now it's a little tricky. We want to color Tennessee, but it's connected to lots of states. So we can't make it blue because it's connected, for example, to Kentucky. Can't make it green, can't make it orange, and that means I'm going to need a 4th color. Let's say purple. So here we were able to do it with 4 colors. Now that doesn't prove that maybe you could have been more clever than me and done it in 3. So we'll stop here, but I want you to think about before Friday, can you color the same graph with 3 colors? Is that possible or not? And then when we come back on Friday, we'll talk about what about the whole United States? How many do you need? And can we prove, or at least discuss, a theorem that tells us for sure whether or not we can do it in 3, 4, 5, and so on. Any questions before we stop? Yeah.
So when you're drawing a graph, what the physical distance of the nodes?
No, so the question was when you're drawing a graph, does it matter exactly where you put the nodes? Or you might ask, like, does it matter how long the edges are? The answer is no. All that matters is you have a node anywhere. They can be close, far, big, small. I could take this exact same graph and rotate it and shrink it or whatever, and it doesn't matter. It's still the same graph. It represents the same information. Any other questions? Okay, let's call it a day then. Please make sure you're giving each other some space as you're exiting, and I'll stand up here for a little bit if you have any questions after class.